Tonight, something gentle and slightly impossible. Time, the thing you trust most quietly, runs slower near anything heavy. A mountain, a planet, a star. Clocks resting at your feet tick a little softer than clocks at your head, and physics, for all its brilliance, still cannot quite say why. We will wander into this together, slowly, here at Midnight Science. Before we begin, tell me, where in the world are you settling in from tonight, and what hour has found you? A soft like and subscribe helps this small, sleepy channel keep drifting along. So here we are, settled in together, in the quiet hours that belong to no one but the listener and the small lamp beside them. Let us begin gently, with the most ordinary thing in the world, the thing that runs through every kitchen, every bedroom, every long evening, every short morning. Let us begin with time. Not the grand cosmic kind, not yet. Not the kind that lives in equations or bends around stars. Just the soft, familiar version of it. The one that lives in your hands when you set down a cup of tea. The one that hums under the kettle while it heats. The one that gathers in the second hand of an old kitchen clock as it nudges itself very slowly around the face. Think of that clock for a moment. The one in your kitchen, perhaps, or the one in the room where you grew up, or the one you remember from somewhere you cannot quite place. There is something tender about a kitchen clock. It is not trying very hard. It is not racing. It is not announcing anything. It is simply there, doing its small, steady work, tick by tick, while the bread rises, or the soup simmers, or someone you love is reading the newspaper at the table. The second hand moves, and you do not really notice it move, but you notice that it has moved. 5 minutes have passed, then 10, and the kettle is whistling, and the afternoon has shifted from one shape into another. This is the time we know best. The time of kettles and clocks and quiet afternoons. The time of mornings that vanish before you have finished your first slow stretch. And evenings that seem to stretch on tenderly. The kind of evenings where the light lingers in the windows long after you thought it would be gone. We all know this time. We grew up inside it. It is, in many ways, the most familiar thing we own. And yet, if you sit with it for a moment, in this quiet room, in this quiet hour, you will notice something rather strange. The same minute does not always feel like the same minute. A minute spent waiting for a kettle to boil is, somehow, longer than a minute spent reading a sentence you love. A minute of waiting at a bus stop in the cold stretches into something approaching forever, while a minute spent watching a small bird outside the window slips through your fingers without making a sound. The clock, of course, does not care. The clock keeps its calm, steady pace. But you, the small living thing watching the clock, feels something more elastic, something more strange. You feel time bend around your attention. This is a small thing, and a familiar one, and probably not worth losing any sleep over. Which is just as well, because losing sleep is rather the opposite of what we are here to do tonight. But it is a small thing worth holding in your hand for a moment, the way you might hold a smooth stone you picked up by a river, because it points at something quietly enormous, something that physicists have spent many lifetimes circling, the simple question of what time actually is. What is time? Such a small phrase, so innocent looking, and yet, if you have ever tried to answer it honestly, you may have noticed that it slips through your fingers the moment you try to hold it firmly. We use time every day. We measure it, we pay for it, we waste it, we save it, we lose track of it, we try to make more of it. We have entire languages and metaphors built around it. And yet, if a small, thoughtful child asked you, in a quiet room, what time actually is, what would you say? You might say, it is the thing the clock measures. But then the clock is just measuring something, and that thing must already be there before the clock was ever invented, before anyone had thought to count anything at all. You might say it is the order in which things happen. But then you have to ask what makes one thing happen before another, and you find yourself standing at the edge of something rather deep. This, of course, is fine. You do not need to answer the small, thoughtful child. The small, thoughtful child is imaginary, and even if it were not, it would probably be asleep by now. But the question lingers in the room with us, gently, like the soft smell of tea. What is time? And how is it that the same minute can feel so different from itself, depending on the room you are in, the person you are with, the patience you have, the kettle you are watching? For a very long time, in the long, slow history of people thinking about such things, there was a beautifully simple answer, and we should sit with it for a moment, because it is the answer that most of us, in our quieter moments, still secretly believe. The answer came, in its most polished form, from a man named Isaac Newton, and I would like to introduce him to you not as a towering historical figure, but as a quiet companion, sitting at his desk in the late hours, in a room not entirely unlike yours, with a small lamp and a window, and the soft sound of someone moving about in another part of the house. Newton was, by most accounts, not a particularly cheerful man. He kept his own hours. He was suspicious of certainty. He was, in many ways, the patron saint of staying up too late, thinking about something just out of reach. We can be very fond of him in the way one is fond of someone who quietly understands what it is to lie awake wondering about the universe. Newton, in his great long working through of how the world might fit together, gave us an image of time that has been with us ever since, and that lives, even now, in the way you and I tend to think about it without quite realizing. He imagined time as something absolute, something universal, something that flowed, in his lovely phrase, equably, the same everywhere, the same for everyone, regardless of where you stood or what you were doing or how heavy the stars above you happened to be. There was, in Newton's picture, one true time, ticking calmly through the whole universe at exactly the same rate. The clock in your kitchen and the clock in a sailor's cabin on a ship halfway around the world, and the clock, if one could imagine such a thing, on a distant planet in a distant galaxy, all ticking together, all sharing the same heartbeat, all keeping time with the same steady, invisible drum. It is, you have to admit, a rather beautiful picture. It is also, in its quiet way, a very comforting one. Imagine it for a moment. Imagine all the clocks in the world, every wristwatch on every quiet wrist, every bedside clock by every sleeping head, every grandfather clock standing patiently in every hallway, all ticking in perfect agreement, all sharing the same calm cosmic pulse. Imagine that the universe itself has a tick, and that every clock is just borrowing it, just listening in. Imagine that even far beyond what you can see, on planets you have never heard of, around stars whose names will never be written down, the same tick is happening, the same second, the same calm, even pace. One vast, agreed upon, universal time, the same for all of us, gently underwriting everything. This is the time that lives in the back of your mind when you say things like, "At this very moment, somewhere on the other side of the world, someone is having breakfast." The phrase only makes sense if there is a shared now, a moment that everyone is in together, a single line of present time stretching across the whole world and indeed the whole universe. We talk this way without thinking. We assume it. We feel it. It is the water we swim in. Of course there is a single now. Of course time is the same for all of us. Of course the second that just passed for you also just passed for me, and for the person reading a book on the other side of the country, and for the cat dozing on a windowsill 3,000 miles away. And it feels true. That is the lovely thing about it. It feels true. Sitting here, in this quiet room, in this quiet hour, with the small lamp doing its small lamp work, it feels obvious that time is the same for all of us. That the universe shares one calm tick. That my second and your second are the same second. That we are all, in some quiet way, marching together through the same long parade of moments, never out of step, never disagreeing, never doubting the count. Newton thought so too, and he had every reason to. Everything he could see, every experiment he could imagine, every observation he could make, supported the lovely, simple picture. Clocks agreed with each other, more or less, once you took care of the small practical wobbles. Falling apples fell at calculable rates. The moon moved around the earth on a schedule one could predict with growing confidence. The whole universe, viewed through the gentle light of Newtonian time, looked like a beautifully tuned orchestra, each instrument playing in time with the same invisible conductor, each note arriving exactly when it was supposed to. There seemed to be no reason at all to doubt it, and there was something deeply restful in not having to. So that was the picture for a long, long time. Time was absolute. Time was universal. Time was the same for everyone, everywhere, no matter what. The clock in your kitchen and the imagined clock on a distant moon were keeping the same time. The universe had one heartbeat, and every clock was just an echo of it. It was a tidy, comforting, perfectly reasonable arrangement. And then, very politely, nature did not agree. It would be quite something if nature had any obligation to be reasonable, but nature, it turns out, has no such obligation. Nature is under no contract with our sense of what ought to be true. Nature does not consult us before it arranges itself. Nature simply is, and we, in our small clever way, sit at our small clever desks and try to write down what we think nature is doing. And now and then nature gently points out that we have missed something rather important. This is, by the way, one of the most charming things about science, not the part where we are right. The part where nature, quite calmly, reveals that we were not quite right, and that the universe is stranger than we had been giving it credit for. I am not going to tell you yet exactly how nature pointed this out, because we are still in the soft early part of the evening, and we have not yet earned the right to say everything we are going to say. But I will plant a small seed for you, the kind of seed that does not need to bloom right now, the kind that can sit quietly in the back of your mind while the rest of the evening unfolds. Here is the seed. Imagine two clocks, perfectly identical clocks, the same make, the same model, the same little second hand, the same little tick. You wind them up at exactly the same moment, on exactly the same table, in exactly the same room. They are, as far as anyone could tell, twins. They are agreeing perfectly. Their seconds are the same seconds. Their minutes are the same minutes. They are, in the gentle Newtonian sense, holding hands. Now you take one of those clocks very carefully and you carry it up a flight of stairs, not very far, just to the top of the stairs, perhaps to a quiet shelf in a quiet room. The other clock stays where it was, in the same calm spot, on the same calm table. Nothing dramatic has happened. No one has shaken anything. No one has dropped anything. No one has whispered anything alarming to either clock. They are just now in slightly different places, one a little higher than the other. That is all. And here, gently, is the strange thing. After some time has passed, days perhaps, or weeks, or months, if you bring the two clocks back together and compare them very, very carefully, with the kind of precision that only certain very patient instruments can manage, the two clocks will no longer agree. The one that lived higher up will be very slightly ahead. The one that stayed lower down will be very slightly behind. Not by much. Not by an amount you would ever notice in ordinary life. Not by enough to make you miss a bus or burn a piece of toast, but by a small, measurable, very real amount. The clocks have disagreed. They have, in some quiet way, lived different lengths of time. This is not a flaw in the clocks. This is not a manufacturing defect. This is not the result of one clock being jostled or warmed or somehow mistreated. The clocks are fine. They are still perfectly identical clocks. What is different is the time they have lived through. The upstairs clock and the downstairs clock have measured different amounts of time. And this disagreement, it turns out, has something to do with gravity. Sit with that for a moment. Just hold it gently, the way you might hold a small, unfamiliar stone you have just been handed. Two identical clocks, in the same building, in the same house, separated only by a flight of stairs. And they disagree. Not because they are broken, not because anyone has tricked them, but because, somehow, time itself is doing something slightly different on one floor than on the other. The downstairs clock has been living more slowly. The upstairs clock has been living more quickly, by an amount almost too small to imagine, but by an amount that is absolutely, unambiguously real. I should say, very gently, that nothing about your house has just become unsafe. The table is still solid. The kettle is still going to whistle when the water is hot. The kitchen clock will still tell you, accurately enough for any human purpose, when supper is ready. The strangeness we are circling tonight does not break anything in your daily life. It hums softly underneath your daily life, never interfering, never causing trouble, never asking to be noticed. You could live your entire life without ever noticing it, and most people do, and that is perfectly all right. Newton lived his entire life without quite noticing it. He was working with the tools he had, and the tools he had could not see this small disagreement. The lovely simple picture held up just fine for everything he could measure, but we now have tools that can see it, and the tools see it everywhere. They see it between the top of a mountain and the bottom of a valley. They see it between the floor of a laboratory and the ceiling of the same laboratory. They see it between the cockpit of an airplane and the runway. it just left. They see it, and once you see it, you cannot unsee it. The simple universal Newtonian time, the one calm tick shared by every clock in the cosmos, turns out to be a lovely approximation, a beautiful first draft, a nearly true story. What replaces it is harder to say and harder to feel, and that is what the rest of our slow evening will be about. But I want to leave you, for now, just with the shape of the mystery. Two identical clocks, one slightly higher, one slightly lower, and somehow time itself ticking just a little differently for each of them, as if the world has a gentle, quiet preference for one place over the other, as if gravity, the thing that pulls things downward, that holds you in your chair, that keeps the cup of tea from drifting up off the table, also, in some quieter, deeper way, has a hand on the second hand of every clock in the universe, slowing it here, speeding it there, whispering to it very gently, depending on where it happens to be. This is, admittedly, slightly inconvenient when trying to relax, but it is also, in its own quiet way, one of the loveliest discoveries we have ever made, because it means that time is not the still, calm, universal background that Newton imagined. It is something more alive than that, something that responds to the world around it, something that listens to gravity and answers very softly in the language of small differences. I want you to come back, just for a moment, to the room you are in, to the small lamp, to the soft surface beneath you, the blanket, the chair, the bed, whatever has been holding you while we have been talking. Take a small, slow breath. The room has not changed. Nothing alarming has happened. The clock in your kitchen, if you have one, is still ticking. The kettle, if you used one this evening, has gone quiet. The world is, as far as the world can tell, exactly as it was. The strangeness we have just touched together does not disturb any of that. It is a soft strangeness. It does not break the world. It just deepens it. The clock at your feet, by the way, is ticking very slightly slower than the clock at your head right now. As you lie here, or sit here, or rest here, your feet are living a tiny, tiny bit more slowly than your head, by an amount no one will ever feel, by an amount no instrument in your home could ever measure. But somewhere, on some very precise atomic clock, in some very quiet laboratory, the difference would be there. The universe has a gentle preference for the floor over the ceiling. It runs its time, very softly, at slightly different rates depending on how close you are to something heavy. And the earth, of course, is something heavy. We will come back to this. We will come back to it many times, in many gentle, different ways, with kindly companions like Einstein joining us along the way, and quiet objects like satellites and stars, and finally, the deepest gravities of all standing in the distance, waiting patiently for us to look at them. But for now, just hold the small first idea. Two clocks, one higher, one lower, a small disagreement, a soft strangeness, a universe that, very politely, does not run on a single calm tick the way Newton thought it might. This is the calm strangeness at the heart of what we are going to wander through tonight. It is not alarming. It does not need to keep you up. In fact, it would be lovely if at any point in our slow evening together, the soft pull of sleep arrived and you let yourself go with it. The clocks will keep ticking either way. The universe will keep doing its quiet work, and I will keep talking softly for as long as you would like to listen. So let us pause here just for a breath. The lamp is still warm. The room is still quiet. Time, as you understand it, is still passing the way it always has, comfortably, unobtrusively, kindly. And underneath it, just out of sight, gravity is doing its small, soft work on the seconds. We will look at that work gently, together, in the next slow movement of the evening. There is no hurry. There is, in fact, all the time in the world, or, as we are beginning to suspect, something quietly stranger than that. So let us turn now, very gently, to the next slow movement of the evening. And to do so, I would like to introduce you softly to another quiet companion in our wander. He arrives without much fanfare, because that is, in the end, how he actually arrived in real life. No trumpets, no lecture halls, no applause. Just a young man at a small wooden desk, in a small office in a small Swiss city, in the early years of a new century. The desk had papers on it, the kind of papers that no one really wanted to read. The papers were patent applications, drawings of inventions, diagrams of mechanisms, bits and pieces of cleverness sent in by people hoping to make their fortunes, or at least their names. And the young man at the desk was paid to read them, to consider them, to stamp them, to file them, to keep the slow, patient gears of bureaucracy turning. His name was Albert Einstein. I would like you to picture him for a moment, not as the famous old man with the wild white hair, but as a young man with dark eyes and a soft mustache and a slightly distracted expression. He is wearing an unremarkable suit. He is sitting very upright at his desk, because the chair is not comfortable. There is a window somewhere in the room, and outside the window the city is quietly being itself, with trams going by and people walking past, and the small, steady sounds of an ordinary afternoon. And inside the room, the young Einstein is doing two things at once. He is reading patent applications, which is what he is being paid to do. And he is also, in the quiet back of his mind, thinking about something else, something larger, something stranger, something he has been carrying around for years and has not yet been able to put down. There is something rather lovely about this image, I think. The very deepest ideas about the nature of time and space and gravity, the ones that would eventually rearrange how we understood the universe, were first turned over in the head of a young man who was technically supposed to be reading paperwork. He was not at a great university. He was not surrounded by famous colleagues. He was not even in a particularly inspiring building. He was just a young person at a desk with a quiet mind and a great deal of patience, doing his job while quietly, gently, gathering one of the most beautiful insights anyone has ever had about the world. He had a habit, this young Einstein, of imagining things, not in the loose way that we sometimes mean it, but in a very particular, careful way. He would set up little scenes in his head, little thought experiments, little imagined situations in which the laws of physics could be looked at from a fresh angle. He would do this on long walks, on tram rides, in the quiet hours of the evening at home. He had, by all accounts, an extraordinary gift for it. He could hold a complicated imagined scene in his mind for a very long time, turning it slowly, looking at it from different sides, asking it patient questions. He was, in a way, an inventor of imagined rooms, and in those imagined rooms, he was quietly working out how the universe might really be put together. One of the imagined rooms that he loved most was a very simple one, a small enclosed space, a box, you might say, or a lift, or what we would call in some places an elevator. Nothing fancy, just a small windowless room with a person inside it. The person inside cannot see out. They can only feel what they feel and observe what they observe inside their small enclosed room. And the young Einstein, sitting at his quiet desk, would let his mind wander into this small windowless room, and he would ask a very gentle question. He would ask, what would it feel like inside? Picture it for a moment with him, very slowly, while the lamp beside you does its small, soft work. You are inside this little enclosed room. The walls are around you. The floor is beneath your feet. There is no window. You cannot see what is outside. You can only feel what your body feels. Now, in the first version of this little imagined scene, the room is sitting quietly on the surface of the earth. The floor is solid. Your feet press against it. You feel a familiar, gentle pull downward, the one you have felt all your life. Your weight settling into your shoes, your body resting comfortably in the chair, the cup of tea you brought with you sitting calmly on the small table beside you, not drifting upward, not floating away, just behaving like a cup of tea ought to behave. This is, of course, gravity, the familiar, quiet pull of the earth holding everything in place. Nothing strange about it. You have known this feeling since the first day you stood up as a small child. It is, in many ways, the most familiar feeling you own. Now, very gently, change the scene. Take the same little room, the same person inside it, the same cup of tea, but lift the whole room far, far away from the earth, far away from any planet, far away from any star, out into deep empty space where there is nothing nearby at all. Now there is no gravity. The room is just floating, and if the person inside the room were just left to drift, they would float gently. The cup of tea would float gently. Everything inside would float, and the feeling would be quite different from what you are used to. There would be no down, there would be no weight. You would feel, in the kindest possible sense of the word, weightless. But the young Einstein, in his quiet imagining, did one more thing to this little room. He attached a rope to the top of it, and then he imagined some invisible, patient hand pulling that rope, very steadily, upward, faster and faster, accelerating the whole little room through empty space, not jerking it, not whipping it, just pulling it smoothly in a steady, accelerated way. And here is the gentle question he asked himself, the one that would, in time, change everything. What would the person inside the room feel? Sit with this for a moment. The room is being pulled upward through empty space. The person inside cannot see out. They cannot see the rope. They cannot see the hand. They can only feel what their body feels. And what their body feels, because the floor of the room is being pushed upward against their feet, is a steady, gentle pull downward, their weight settling into their shoes, their body resting comfortably in the chair, The cup of tea sitting calmly on the small table beside them, not drifting upward, not floating away, just behaving like a cup of tea ought to behave. You see what is happening here. From the inside, the two situations are identical. The little room sitting quietly on the surface of the earth, and the little room being gently pulled through empty space, feel exactly the same to the person inside. There is no test they can do, no experiment they can run, no measurement they can take inside their small enclosed room that will tell them which of the two situations they are actually in, whether it is gravity holding them down or acceleration pushing them up. From the inside, the two are indistinguishable. They are, in a very quiet but very deep sense, the same thing. Let me say that again, softly, because it is a thing worth hearing twice. Standing on the floor of a room on the surface of a planet, and being inside a room that is being gently accelerated upward through empty space, feel exactly the same. The pull of gravity and the push of acceleration produce the same feeling on your body, the same behavior in your cup of tea, the same little world inside the room. They are, as far as the inside is concerned, one and the same. This little idea, the one that Einstein turned over and over in his head until it became smooth and worn, like a stone in his pocket, has a rather grand-sounding name. It is called the equivalence principle. The word principle makes it sound rather technical and admittedly does not arrive carrying a basket of friendliness. But underneath the name, it is a very gentle thought. Gravity and acceleration, when you are inside the room, are equivalent. They feel the same. They are, in some deep sense, the same. And let me say it a third time more softly still, because I suspect you may have drifted for a breath, and that is all right. You are very welcome here. The pull you feel right now, the soft weight of your body against whatever is holding it, the way your hand rests on the blanket, the way your head settles into the pillow, this feeling, this familiar earthly feeling, is exactly the same feeling you would have if you were not on Earth at all, but inside a small windowless room being patiently accelerated through empty space by some invisible hand. From the inside, you could not tell the difference. The cup of tea would not know the difference. The clock on the wall would not know the difference. Gravity and acceleration are, in the quiet language of physics, two ways of saying the same thing. This is a lovely idea and a strange one, and the kind that, once you have it, you start to feel as though it should perhaps come with a small gentle warning label, because it leads, very softly, to a conclusion that you almost do not have to be told. You can simply let your mind drift toward it on its own. If you remember what we talked about in the last quiet movement of the evening, about how acceleration and motion can stretch the way time is experienced, you may already be feeling the next thought arrive. You may be feeling it gather very gently at the edges, because if acceleration affects how time is experienced, and gravity feels exactly like acceleration from the inside, then gravity must affect how time is experienced too. The two cannot be separated. If one bends time, the other must bend it as well. It is not a leap. It is barely even a step. It is more of a quiet settling, the way water settles after you stop stirring it. You stand on the floor of a room on the surface of the earth, and time is doing something, very gently, in response to the gravity around you. It is not the same time it would be if there were no earth beneath you. It is a slightly slowed, slightly different time, kept just a touch behind by the soft pull of the world, the young Einstein, sitting at his quiet desk, with his unread patent applications and his small, unremarkable suit, followed this little chain of thoughts wherever it led him. And it led him somewhere rather beautiful. It led him to a picture of the universe in which gravity and time and space were all woven together into one quiet living thing. Not three separate things sitting next to each other, but one thing, all of a piece. He gave this thing a name, or rather, a name was given to it, and the name is one you have probably heard. The name is space-time. I want to say space-time carefully, because the word is a little misleading in its smoothness. It sounds like a single thing, neatly tied up. But what it really means is something much gentler. It means that space and time are not two separate stages on which the world performs. They are one stage. They are woven together. What happens to one happens, in some quiet way, to the other. You cannot move through space without also moving through time. You cannot bend time without also bending space. They are, in the deepest sense, one fabric. And there, you see, is the word that always arrives at this point in any story like ours. Fabric. The image of a fabric. A soft sheet, perhaps, stretched out gently, the way you might stretch a thin sheet across a bed. Smooth, calm, unmarked. And then, if you place something heavy on it, a small stone, a heavy book, a sleeping cat, the sheet dips, it curves, it bends downward where the heavy thing rests. Other small things, if you place them on the sheet, will roll toward the dip. They will fall in their gentle little way toward whatever heavy thing has made the curve. And in our story, the heavy things are stars and planets and moons, and the curving of the fabric is what we have been calling gravity all our lives. I would like to say, very honestly, that this image must be handled with care. It is the kind of image that physicists use a little reluctantly, because the sheet, the fabric, the soft cloth that dips under heavy things is only a metaphor, and only a partial one. The real space-time of our universe is not a flat sheet stretched out in some larger space. There is no above the sheet and no below the sheet. There is no edge where the sheet ends. The fabric, if we are to use the word, is not a thing inside the universe. It is the universe. It is the whole gentle structure of everything, all at once, woven together, with no outside. So we must be a little careful with our image. We use it because it is useful, the way one uses a small candle to look at a large, dark room. The candle does not show us everything, but it shows us enough to begin. And the small candle of the soft sheet shows us, gently, the heart of the idea. Mass curves the fabric of space-time. Heavy things, just by being there, change the shape of what is around them. And what we call gravity is, at its very root, this curving. Not a mysterious invisible pull, not a hand reaching across empty space to tug you downward. Just the soft shape of a fabric, gently bent by the weight of a world. And you, sitting calmly inside that bent shape, behaving as small things behave, when the fabric they are in has a soft dip in the middle of it. This is the picture that the young Einstein, at his quiet desk, gradually arrived at. It took him years. It took him many imagined rooms, many imagined lifts, many long walks in many quiet evenings. He was not in any hurry. He let the idea ripen slowly, the way fruit ripens on a tree, in its own gentle time. And when at last he wrote it down, it became one of the most beautiful theories anyone has ever written, the one we now call general relativity. The word general just means that it is the bigger, broader, fuller version of an earlier theory. It is the one that includes gravity. It is the one that includes the heavy things. It is the one that lets the fabric bend. And inside this beautiful theory, something rather important and quite tender lives. Something we touched on just barely in the first movement of the evening, and that we are now ready to hold a little more clearly. The curving of the fabric does not just bend space, it also bends time. The two are woven, remember, they are one thing. So when a heavy world like the Earth makes its soft dip in the fabric of space-time, that dip is not only a dip in space, it is also a dip in time. And what that means, in the most ordinary and gentle way, is that time itself runs a little more slowly inside the dip than it does out at the edges. Take a small, slow breath with that. There is no hurry. The room around you is still quiet. The lamp is still warm. The blanket is still settled gently over you. Nothing in your life has changed. But the picture has shifted just a little. The ground beneath you is not, in the strictest sense, pulling on you. Not the way Newton imagined it anyway. There is no invisible string from the center of the earth tugging at your bones. What is happening, in the deepest soft language of the universe, is that the earth, by being heavy, has made a quiet dip in the fabric of space-time, and you, by being inside that dip, are experiencing time at a very slightly slower rate than you would if you were further away. Time, at your feet, very close to the earth, runs a tiny bit slower than time at your head, slightly further from the earth. And what we call your weight, what we have always called gravity, is, in part, the soft consequence of that slowing. The ground beneath you is not so much holding you down as it is whispering to your seconds, telling them to take their time, to move just a little more slowly than the seconds higher up. This is, admittedly, slightly inconvenient when trying to relax. The idea that the ground beneath you is, in a quiet way, slowing time at your feet, is the kind of idea that you do not necessarily want to be holding in your head while you are also trying to drift off to sleep. So let me say, very gently, that this is not something you have to worry about. The slowing is impossibly small, on a scale you will never feel. Your feet are not going to age noticeably more slowly than your head. By the end of a very long life, you might come out, by some impossibly tiny measure, a fraction of a second younger at the soles than at the crown. The kind of difference that no clock in your home, no watch on your wrist, no internal sense of the passing of hours will ever notice. The strangeness is real, but it is also very, very small, and it does not interfere with anything you care about. It just hums softly underneath your daily life, telling its quiet story. But the strangeness is there. That is the gentle point. Once you have seen it, even if it is a small thing, even if it does not change your day, it has changed the picture. The world is no longer quite the same. The ground is no longer just pulling, it is also slowing. The kitchen floor under your feet is very softly, keeping your seconds a touch behind the seconds of the ceiling. The whole house, the whole town, the whole planet is sitting inside the gentle dip of space-time that the Earth has made. And inside that dip, time is running just a little more slowly than out at the edges. The closer to the heavy thing, the slower the tick. The further from the heavy thing, the slightly quicker the tick. And this is not a quirk of the clocks. It is a feature of time itself. I want you to come back to the small room you are in, the small lamp, the blanket, the soft surface beneath you. Take a slow breath. Notice the way the air feels as it moves in and out. Notice the way your weight is settling into whatever is holding you. That weight, that familiar, quiet pull, is the gentle pressure of a world beneath you that has, by being what it is, made a soft dip in the fabric of everything. And inside that dip, your seconds are being whispered to. Not aggressively, not alarmingly, just softly, the way a kind voice might say, "Take your time." The Earth is, in a sense, telling your feet to take their time, and your head, very slightly higher, is being told to take its time just a touch less slowly. This is a strange picture, and a lovely one, and one we will keep coming back to as the evening continues. We will look, in our next slow movement, at little machines we have built that live high above the earth, machines that have to take this small, soft slowing of time very seriously indeed, because if they did not, they would not be able to guide you home. We will look at the small, calm twins of an old thought experiment, one who stays near the world and one who drifts away, and at how they come back to each other holding slightly different lengths of life. We will let the strangeness deepen, gently, the way water deepens as you walk further from the shore. But for now, just rest with the new image. The ground beneath you is not so much pulling, it is curving, and the curving is not just in space, it is in time. The world you are lying on, or sitting on, or settling into, has made a small, soft dip in the great, quiet fabric of everything. And inside that dip, your time, the time of your body, the time of your breath, the time of your heart, is running just a tiny bit more slowly than it would if you were far away from any world at all. You are, in the gentlest possible sense, swimming in slowed time, and you have been swimming in it your whole life, and you have never had any reason to notice, because everything around you is swimming in it too, at very nearly the same rate. The young Einstein, at his quiet desk in his unremarkable suit, would have liked this. He had a great fondness for ideas that did not disturb the world. He liked it when the universe could be both stranger and stranger than we had thought, and yet still continue, calmly, to be itself. The kettle still whistles. The kitchen clock still ticks. The cup of tea still sits on the table without drifting away. And underneath all of it, very gently, time is doing its small, soft, uneven work, slowing here, quickening there, listening, always, to the soft shape of the heavy things around it. Let us pause here, just for a breath. The lamp is still warm. The blanket is still settled. The room is still quiet. And the small, strange, beautiful thing we have just looked at together The curving of time by the weight of a world will sit gently in the back of your mind while we move, in our own unhurried way, into the next slow movement of the evening. So let us turn now, very gently, to something rather lovely, because so far in our slow evening together, the strangeness we have been touching has been a quiet kind of strangeness. The kind that lives in tiny invisible differences between clocks on different shelves, in soft theoretical pictures of fabric and dip and curve. It is the kind of strangeness that you can hold in your mind without it affecting your day in the slightest. The kitchen floor is still solid, the kettle still whistles, the cup of tea still sits on the table. The world goes about its business as it always has. And yet, the curving of time by the weight of a world is not just a soft theoretical thing. It is a real thing, a measurable thing, a thing that, as it happens, lives in the small machine in your pocket, the phone on your bedside table, if you have one nearby, the small glowing thing that may have been the very last thing you looked at before settling in for the night. That phone, in the quietest possible way, depends on this strangeness in order to do its small daily work. The strangeness that you and I have been gently circling, the slow, soft slowing of time near a heavy world, is not an exotic phenomenon that lives only in expensive laboratories. It is in your hand. It has been in your hand for years. It has been guiding you home. I would like to ask you, if you are still with me, to do something rather small and rather lovely. I would like you to imagine, just for a moment, the sky above the roof you are under right now. The sky above your house, your room, your bed, your blanket, the night sky perhaps with its quiet stars, or the cloudy sky if it is cloudy where you are, or just the soft empty air above the ceiling, the part of the world that lives between you and outer space. And I would like you to imagine drifting through that sky, far above the roof of your house, a small number of quiet, patient machines. They are not very big, these machines. They are about the size of a small car, perhaps, with little outstretched wings of solar panels catching the sunlight even now, even while it is dark where you are. They are sitting up there in the cold, far above the weather, in the long, calm silence of space. There are around 24 of them, spread out in a thin lacework around the planet, each one quietly orbiting at a height of about 20,000 kilometers above the surface of the Earth. That is rather far. Far enough that the Earth looks like a small blue marble from up there. Far enough that the curve of the planet is plain to see. Far enough that the weather, the clouds, the storms are all happening on a small, soft sphere underneath them. And these little machines, drifting in their gentle orbits, are doing one small thing over and over, calmly, faithfully, for as long as they continue to exist. They are sending down time. That is, in the deepest sense, what they do. They are time machines. Not in the dramatic story sense of the word, just in the quietest, most literal sense. They each carry, inside them, one of the most precise clocks ever built. Atomic clocks. Clocks that do not tick the way the kitchen clock ticks. Clocks that measure the steady, patient pulse of a particular kind of atom with such delicate precision that they would, if left alone, gain or lose only a few seconds over the entire age of a long human life. These are clocks of an almost unimaginable steadiness, and the small patient machines up there, carrying these clocks, do nothing all day, every day, all night, every night, except whisper down in the form of radio signals the time that their clocks are keeping. The signals fall through the night sky, very quietly, completely invisible, completely silent. They pass through clouds, through rain, through the windows of your house, through the walls of your bedroom, through the small case of the small phone on your bedside table. The phone, when it wishes to know where it is in the world, listens for these signals. It collects them from several of the little machines at once, and then, by comparing the small differences in when each signal arrives, by doing some very quick patient arithmetic, the phone figures out where on the surface of the planet it must be sitting. It figures out where you are, and it places a small glowing blue dot on a map with kind, reassuring confidence, as if to say, "You are here. You have not gotten lost. The world has been keeping track of you, gently, the whole time." This little system has a name. It is called the Global Positioning System, although mostly we just call it GPS, the way we call most lovely complicated things by their initials. And it has, in the years since it was first made fully available to ordinary people, quietly transformed how we move around the world. The friendly voice in your car that tells you to turn left in 200 meters. The small blue dot on the map that follows you patiently through an unfamiliar city. The way a stranger across the country can know, if you let them, exactly where you are standing. All of this, all of it, rests on those small, drifting, patient machines, sending down their soft, constant whispers of time. And here, very gently, is the strange and tender thing about them. Those clocks on those machines, up there in their high orbits, do not tick at the same rate as the clocks on the ground. They tick a little faster, not because they are broken, not because they were built slightly differently, not because anyone has wound them too tightly. They tick faster because they are higher up in the soft dip of space-time that the Earth has made. They are sitting further from the heavy thing. They are out toward the gentler edge of the curve. And out there, as we touched on in the last slow movement of the evening, time runs just a little more quickly than it does down here, near the surface, deeper in the dip. How much more quickly? This is the part where the strangeness reveals itself in numbers, and I will share them with you very softly, because numbers can sound rather imposing if they are spoken too loudly, and we are not in any kind of mood for imposing things tonight. The clocks on those satellites, compared to the clocks on the ground, run faster by an amount of about 38 microseconds per day. A microsecond is 1/1,000,000th of a second. So 38 microseconds is 38 millionths of a second. Tiny, almost laughably tiny, smaller than the time it takes for any thought you have ever had to even begin forming. 38 millionths of a second per day. This is the kind of number that sounds on its first arrival completely harmless. It sounds like the sort of difference that would not matter to anyone, ever, for any reason. It is the kind of difference you might find between two perfectly good kitchen clocks after 100 years of patient ticking. It is, on the surface of it, the sort of difference one would happily ignore, until you remember, gently, what those signals are doing. The signals from the satellites travel at the speed of light. Light moves very, very quickly. In 1/1,000,000th of a second, light travels about 300 meters. That is roughly the length of 3 football fields, end to end, in the time it takes for a single tick of a millionth of a second. So a difference of 38 millionths of a second multiplied by the speed of light gives you an error of about 11 kilometers. 11 kilometers every single day of accumulating mistake. If the small, clever people who built the GPS system had not accounted for the soft curving of time, the blue dot on your phone would, after one day, be telling you that you are 11 kilometers away from where you actually are. After 2 days, 22 kilometers. After a week, more than 70 kilometers. After a month, the map would be entirely meaningless. The whole system would, very politely, fall apart. You would, in some literal sense, be told that you were in a different country. This is, when you sit with it, a rather remarkable thing. The global positioning system, the small, unassuming feature of modern life that helps you find your way to a restaurant, that guides delivery vans through neighborhoods, that tells lost hikers where they are, that quietly underpins almost every map you have ever looked at on a small screen, would not work at all if the engineers who built it had not taken the soft dip in time around the Earth seriously. The whole thing depends on Einstein. Every blue dot, every gentle voice telling you to turn left. Every recovered key set, every found pet, every reunion, every small navigated journey home through unfamiliar streets. Einstein has been there, in the back of it all, quietly helping. I find this a tender thing to sit with, and perhaps you do too. The very deepest soft strangeness of how the universe is put together, the curving of time around heavy worlds, the bending of seconds by the weight of a planet, has not stayed locked away in old papers and dusty equations. It has come down to us. It has slipped into our pockets. It has become the small, everyday miracle of knowing where you are. Every time you have ever looked at a map on your phone and seen the small, confident blue dot showing you your place, the universe has been doing some patient, quiet, relativistic arithmetic for you. The young Einstein at his small desk with his unread patent applications would, I think, have been quietly pleased. It is worth saying, by the way, that this is not the only relativistic effect those little machines have to worry about. There is also a smaller effect that comes from the fact that the satellites are moving very quickly, and motion, in its own quieter way, also bends time. The two effects pull in opposite directions, and they partly cancel each other out, but the gravity effect is the larger of the two, and the net result is that the clocks up there really do gain those 38 microseconds every single day. The engineers, before launching the satellites, very politely set the clocks to tick at a slightly slower rate on the ground, so that when they arrived in orbit, where time runs a touch faster, they would tick at exactly the right rate to agree with the ground. They have to be deliberately mistuned on Earth in order to be correctly tuned in space. It is, in its quiet way, one of the most quietly poetic acts of engineering anyone has ever performed. Let us sit with this for a moment in the small room you are in. The phone, if it is near you, is silent now. The blue dot, if it is showing, is small and steady, telling you that you are right where you are. Above you, far above the roof, in the cold, patient silence of orbital space, those little machines are still doing their work. They are still whispering down their time signals. They are still tuned to a slightly different rate, because the soft dip of space-time around the Earth has been factored into how they were built, and every signal they send is, in its quiet way, a small message from the universe, reminding us that time is not the universal calm tick of Newton, but something gentler and stranger and more alive. I would like, if you will allow it, to drift now toward another small image, one that has lived in the soft imagination of physics for a very long time, and that you may have come across before in some version or another. It is sometimes called the twin paradox, although I will be quite honest, I do not particularly love the word paradox in this context. It is not really a paradox. It is just a small, tender thought experiment, and I prefer to frame it that way. Let us call it, for our purposes tonight, the story of the two siblings. Imagine two siblings then. They could be any siblings you like. Twins, traditionally, because twins make the thought experiment cleanest, but you can picture them any way you wish. They are very close. They love each other. They grew up together. They have shared a great many quiet evenings in their lives. And now, in this small, imagined version of their story, one of them is going to stay near a heavy world, near a planet, near home, in the same soft dip of space-time they have always lived in. And the other is going to drift away, very far, into the gentler edges of the universe, out where the dip is softer, out where time runs at a slightly quicker pace. The journey of the one who leaves takes years, many years. The one who stays at home goes about their life. They have meals. They have winters and summers. They watch the leaves change. They read books. They miss the sibling who has gone. They wait. And one day, the sibling who left comes home. The ship, the long patient journey, the great wide loop through the universe, all finished. The traveler steps back into the same small house, and the two siblings stand in front of each other, and they look at each other, and something quiet and tender and slightly sad happens. The one who stayed has aged. The one who traveled has also aged, but not by the same amount. The one who traveled, who spent so much of their journey out in the gentler edges of space-time, has come home younger. The one who stayed has come to greet them older. They are still siblings. They still love each other. But their lives, in some quiet way, have come apart in length. They have not lived the same amount of time, even though they were born on the same day. This is, as I said, sometimes called a paradox, but I would gently suggest that it is not a contradiction. It is a tenderness. It is the soft consequence of what we have been talking about all evening. Time is not the same everywhere. Time depends on where you have been and how you have moved and what gravities you have moved through. The sibling who stayed near home spent their life inside the soft dip of a planet where the seconds ran a little more slowly. The sibling who left spent much of their life out at the gentler edges, where the seconds ran a little more quickly. And so, when they come back together, they meet across a small, soft gap of time. The years have been kind to them differently. I think there is something very gentle and very honest about this little story, and I think it touches on something quite real about love, although I do not want to push too hard on that. It is, in some ways, a soft picture of what happens in any long relationship between people whose lives diverge for a while. The one who stays and the one who goes do not, when they return to each other, find themselves in exactly the same place. Time has done its quiet, uneven work on each of them. The universe, it turns out, has known this all along, and has built it gently into the very fabric of how things move. The twins, the siblings, the imagined travelers are not an exotic puzzle. They are a small, kind, tender truth about how time works. We do not have, of course, any actual humans who have traveled fast enough or far enough for this effect to be plainly visible to the eye. The siblings of the thought experiment have not yet existed in real life in any dramatic sense, but the effect itself, the small, soft difference, has been measured. There have been experiments, very patient ones, where atomic clocks were placed on airplanes and flown around the world, and were then brought back to compare with clocks that had stayed on the ground, and the clocks did not agree. The clocks that had flown returned with a small difference, a very small difference, but a real one, exactly the difference that the soft theoretical picture had predicted. Time had run, very slightly, at different rates for the flying clocks and the resting ones. And we, the small clever beings doing the measuring, were able to see it and to nod gently and to say, yes, time really does this. Time really is this gentle and this strange. So I would like, before we let this slow movement of the evening settle, to do a small, soft recap, just to gather the things we have touched together, the way you might gather small stones at the end of a walk by the shore. We began the evening with the calm, familiar time of kitchens and kettles. We met Newton, very kindly, and his lovely picture of one universal tick, the same everywhere for everyone. We met the small seed of trouble, the idea that two clocks at different heights can disagree. We met the young Einstein at his quiet desk and his imagined room being pulled gently through space, and the lovely deep idea that gravity and acceleration feel the same from the inside. We let ourselves arrive at the conclusion that gravity must bend time as well, that the heavy world beneath us is, in some soft sense, slowing the seconds at our feet. And tonight, in this slow movement, we have brought that strangeness into the small, ordinary world of phones in our pockets and blue dots on our screens, of small machines drifting high above us in patient orbits, of siblings parting and returning across uneven lengths of life. I want to say, before we close this movement of the evening, that the table beneath whatever you are resting on is still solid. The blanket is still soft. The lamp is still warm. The kitchen clock, if you have one, is still ticking calmly. Nothing about the world you live in has actually changed. You still know how to make a cup of tea. You still know the way to the corner shop. You still know the names of the people you love. The strangeness we have been touching does not, in any practical sense, disturb your daily life. It hums softly underneath everything, but it does not break anything. It does not turn the floor into a question. It does not make the door uncertain. It just gently reminds us, when we choose to listen, that the world we live in is a little stranger than it usually looks. A little stranger, perhaps, in a way that is almost tender, because consider it. You are lying in a room, or sitting in a room, or settled into a corner somewhere on the surface of a small blue planet. And above you, far above the roof, those little machines are still drifting in their high, cold orbits, still whispering down their patient signals of time. And inside the small phone on your bedside table, the universe has been doing its quiet, patient work, the soft arithmetic of curved time, just so that, when you next need to find your way home, the small blue dot can be where it ought to be. And somewhere in the gentle, imaginary parts of physics, there are two siblings, parting and returning, returning and parting, reminding us in their soft, small way that the time we share is not as universal as we used to think. It is, when you settle with it, a kind of strangeness. A strangeness that has been working quietly in your pocket for years, helping you find your way. A strangeness that lives in the patient atomic clocks above your roof. A strangeness that lives in the soft theoretical picture of siblings whose lives drift apart at unequal rates. A strangeness that does not break the world, that does not threaten the lamp or the blanket, that does not insist that you stay awake. A strangeness that just sits very gently alongside the kettle and the kitchen clock and the cup of tea, asking only that you notice it. Every now and then, when you happen to look up, we will, in our next slow movement together, turn the dial just a little further. We will leave the soft gravity of our small blue planet and visit, very gently, some heavier worlds, places where the dip in the fabric is steeper, where the soft slowing of time is no longer measured in microseconds, but in something a little stranger still. We will not go alarmingly. We will not go in a hurry. We will go the way one wanders through a quiet museum at night, lamp in hand, looking at one room and then the next, in our own unhurried time. The table is still solid. The lamp is still warm. The world is, very gently, stranger than it looks. And that, in its own quiet way, is one of the loveliest things about it. So let us turn now, very gently, to some heavier things. And I do mean that quite literally. So far, in our slow evening, the gravities we have visited have been soft ones. The gentle pull of our own small blue planet. The barely measurable difference between a clock on a shelf and a clock on the floor below it. The 38 microseconds a day that the little machines above your roof have to account for. These are real effects, and lovely ones, but they are also, in the grand scheme of things, very mild. The dip that the Earth makes in the fabric of space-time is, when you stand back and look at it, a rather shallow dip, a gentle saucer of a dip. The kind of dip a small stone makes when you set it down on a thin, stretched sheet. Just enough to slow your seconds by an amount no one will ever feel. But the universe, as it happens, contains heavier things than our small blue planet. Much heavier things. And tonight, very gently, in our own unhurried time, I would like to take you to visit a few of them. Not to alarm you, not to keep you awake, just to wander the way one wanders through the quiet, far rooms of a museum at night, lamp in hand, looking at the strange, beautiful objects that the cosmos has, over its long, patient history, managed to make. We will visit them as distant, quiet companions. We will not get too close. We will simply stand at a respectful distance and look and let the strangeness of them settle softly over us. Let us begin with a star that has finished its life. You may know that stars, like most things, do not last forever. They are born in great soft clouds of gas, and they shine for a very long time by the patient burning of their own substance, and then, at last, they come to the end of what they have to burn, and they change. Our own sun will do this one day, far in the future, long after everything we know has passed. It will swell and shed its outer layers very gently into a soft, expanding cloud, and at the center of that cloud it will leave behind a small, dense ember of what it used to be. That small, dense ember has a name. It is called a white dwarf, and it is the first heavier thing I would like you to look at with me tonight. A white dwarf is, in a way, a rather poignant object. It is what is left of a star after the star has stopped shining in the ordinary way. It is the cooling cinder at the heart of a life that has ended. And it is small, surprisingly small. A white dwarf can contain as much material as our entire sun. All of it, the whole vast bulk of a star, squeezed down into a sphere about the size of a small planet. About the size of the Earth, in fact. Imagine that for a moment, very softly. Take the sun, the great, enormous sun, the one so large that more than 1,000,000 Earths would fit inside it, and squeeze all of that down until it is no bigger than the small blue world you are lying on right now. That is a white dwarf, a whole sun packed into the space of a single small planet. When you pack that much material into that small a space, the gravity at the surface becomes very strong indeed, much stronger than anything you have ever felt. If you could stand on the surface of a white dwarf, which you could not, for a great many reasons, but if you could, you would feel a pull so strong that your body simply could not bear it. And the dip in space-time that the white dwarf makes is correspondingly deeper, not a gentle saucer like the Earth makes, something steeper, something more pronounced. And inside that deeper dip, time runs more slowly than it does here in your room, not by 38 microseconds a day, by rather more than that. A clock sitting on the surface of a white dwarf would tick measurably slower than the clock on your kitchen wall. If you watched it from a safe distance, you would see it falling behind, very gently, second by second, hour by hour, the slow, soft consequence of sitting so deep in the curve. This is, already, a stranger thing than the soft gravities we have been visiting. And yet a white dwarf is not even the heaviest thing the universe has made from the death of a star. There is something denser still, something that makes the white dwarf look almost roomy by comparison. And I would like to introduce it to you very gently, because it is one of the strangest objects in all of existence, and it deserves to be met slowly, with a little care, the way you might be introduced to a very old and very unusual relative at a quiet family gathering. It is called a neutron star, and it is what is left when a much larger star, a star much bigger than our sun, comes to the end of its life and collapses. The collapse of such a star is a dramatic thing, but we are not here for the drama tonight, so let us skip gently past it and arrive at what is left behind. What is left behind is a sphere, a small sphere, only about 20 kilometers across, 20 kilometers. That is the size of a small city. You could, in principle, walk across it in an afternoon, if walking across it would not instantly destroy you, which it would. A small sphere, the size of a city, and inside that small city-sized sphere, there is more material than there is in our entire sun. More than a whole sun, squeezed not into the size of a planet, as with the white dwarf, but into the size of a city. I want to give you one small image of just how dense this is, and I will give it to you softly, because it is the kind of image that can feel almost dizzying if you say it too loudly. On a neutron star, the material is packed so tightly that a single teaspoon of it, just one small teaspoon, the kind you might use to stir sugar into a cup of tea, would weigh as much as a mountain, as much as an entire mountain. 1 teaspoon. If you could somehow scoop up a single teaspoon of neutron star material and bring it back to Earth, which you could not, it would weigh as much as a great peak, the kind of mountain that takes days to climb, the kind whose summit disappears into the clouds. All of that weight in a teaspoon. This is, admittedly, a difficult thing to hold in the mind, and I do not want you to strain to hold it. Just let it drift past you, gently. A teaspoon is heavy as a mountain. The universe is, it turns out, capable of making material that dense, that strange, that heavy. And it has made a great many of these neutron stars, scattered across the galaxy, small, dense, city-sized spheres, each one carrying the crushed remains of a star much greater than our Sun, each one sitting in a dip in space-time so steep that it bends not only the fabric around it, but the very seconds that pass nearby. Because here is the part that brings us back, gently, to the heart of our evening. On the surface of a neutron star, time runs noticeably slower than it does in your room. Not microseconds a day, something far larger than that. If you could stand on the surface of a neutron star, which again you could not for so many reasons, but if you could, and if you could somehow survive there and look up at the rest of the universe, you would see the universe running fast, the stars wheeling more quickly than they should, distant clocks racing, and if someone far away could watch you standing on that surface, they would see you moving slowly, your every gesture stretched out and lingering, your seconds falling steadily behind theirs. The difference would be substantial. On some neutron stars, time at the surface runs at perhaps 70 or 80% of the rate it runs out in open space. Imagine that. For every hour that passes far away, only 40 or 50 minutes pass on the surface. The soft slowing we measured in microseconds around the Earth becomes, here, a slowing you could very nearly feel. A slowing that would, over a lifetime, leave you years out of step with the rest of the cosmos. This is, I think, one of the most quietly astonishing facts about the universe. That there are places, real places, that genuinely exist, scattered through our own galaxy right now, where time runs slow enough to matter, where an hour is not an hour, where the simple, even tick that we grew up trusting becomes something stretched and slowed and visibly strange. These are not theoretical places. They are not imagined rooms or thought experiments. They are real objects with real surfaces, sitting in real dips in the real fabric of space-time, slowing real time right now while you lie here in your quiet room. Somewhere out there on the surface of some small, dense city-sized sphere, the seconds are crawling, and they have been crawling for millions of years, and they will go on crawling long after the kettle in your kitchen has rusted away to nothing. I should pause here and reassure you, very gently, that none of this is anywhere near you. The nearest neutron star is many, many light years away, far beyond anything that could ever trouble your small blue planet. You are in no danger. The strangeness of these objects does not reach down to disturb your room. They are quiet, distant companions in our inquiry, nothing more. We are looking at them through the lamplight of imagination from a great safe distance, the way one looks at a strange, beautiful animal in a far enclosure at a zoo. They cannot reach you. They are simply there, being strange, being heavy, being slow while you rest. And I will admit, with a small, soft smile, that physicists already have quite enough heavy things to carry without these. The white dwarfs and the neutron stars are, in a sense, the universe being almost unreasonably dramatic about its weights. A teaspoon as heavy as a mountain is the kind of thing that, if a person proposed it as a research program, you would gently suggest they go and have a lie down. And yet there they are. The universe did not consult anyone before making them. It simply made them the way it makes everything, calmly, without asking, and left us to come along afterward and try to write down what it had done. But I would like to draw out something now, gently, that has been quietly gathering underneath everything we have looked at tonight. Because it would be easy, when hearing about neutron stars and white dwarfs, to think of this slowing of time as a kind of exotic effect, something that only happens out there, in the extreme places, on the surfaces of crushed stars and dense, city-sized spheres. It would be easy to think that time runs slow only where gravity is enormous, only where the dips are steep, only in the strange far rooms of the cosmic museum. And that is, in a way, where the slowing becomes large enough to notice. But the slowing itself is not exotic. The slowing itself is not rare. The slowing itself is everywhere. This is the gentle thing I would like you to hold. Time dilation, the soft slowing of time near mass, is not a glitch. It is not a rounding error. It is not some strange exception that crops up only in unusual places. It is a fundamental feature of the universe. It is woven into the very fabric of how everything works. It is present wherever there is mass, which is to say, it is present everywhere. There is no place in the universe where mass exists and time is not, in some small soft way, slowed by it. The neutron star slows time enormously because it is enormously dense. The Earth slows time very slightly because it is much less dense. And you, lying here in your quiet room, you also slow time. Your own small body, with its own small mass, makes its own impossibly tiny dip in the fabric of space-time and slows the seconds around it by an amount so small that no instrument that has ever been built, or perhaps ever could be built, would be able to measure it. But the slowing is there. It is there because you are made of mass, and mass slows time, always, everywhere, without exception. And it is there, too, within your own body. We touched on this gently in an earlier movement of the evening, and I would like to return to it now, because it deserves to be felt fully. Right now, as you rest, the time at your feet is running very slightly slower than the time at your head, because your feet are very slightly closer to the heavy earth than your head is. They are sitting a little deeper in the dip, and so they are living very slightly, more slowly. Over the course of your whole life, this amounts to a difference so small that it would take an extraordinarily precise atomic clock to even begin to detect it. By the end of a long life, your feet might come out a few billionths of a second younger than your head. The kind of difference that means nothing, that changes nothing, that you will never feel and never notice. And yet it is real. It is genuinely real. You are, right now, a single small person living at very slightly different rates of time in your different parts, because you are stretched across a tiny range of heights in the gentle dip of a planet. This is the soft truth underneath everything. time dilation is not something that happens to other people, in other places, on the surfaces of distant, crushed stars. It is happening to you, right now, in your own quiet room, in your own resting body. It is happening to the cup on your bedside table, whose bottom is living very slightly more slowly than its rim. It is happening to the lamp, to the blanket, to the floor, to the ceiling. Every object in your room is, in its own impossibly small way, sitting in the dip of the earth, having its seconds gently slowed. The whole room is full of slightly different times, all running at slightly different rates depending on their height, all so close to each other that they seem, for every human purpose, to be the same. And this brings me, gently, back to where we began the whole evening, to the kitchen clock, the old kitchen clock with its slow, patient second hand, ticking calmly on the wall while the kettle heats and the afternoon shifts from one shape into another. When we first looked at that clock, at the very start of our evening, it seemed like the simplest thing in the world. A clock, a tick, time, plainly passing, the same for everyone, the most ordinary object imaginable. But look at it now. Look at the kitchen clock now, with everything we have gathered tonight. That second hand, sweeping calmly around the face, is measuring time at the particular height it happens to hang on the wall. A clock hung higher on the wall would tick, very slightly, faster. A clock placed on the floor would tick, very slightly, slower. The clock is not measuring some universal, even tick that fills the whole cosmos. It is measuring the local time, the time at that exact spot, at that exact height, in that exact small dip in the fabric of space-time that your house sits inside. It is a local instrument, reporting a local time, and if you carried it to the top of a mountain, or down into a deep valley, or up to the high cold orbits where the little machines drift, it would tell you a slightly different story. The kitchen clock, the most ordinary object imaginable, turns out to be quietly reporting on the shape of space-time in your kitchen. It always was. We just did not know to listen. I find this a rather tender thing, that the simplest object in the house, the calm, patient kitchen clock, has been telling us all along something profound about the nature of time. It has been keeping the local time of its particular spot in the gentle curve of the world faithfully, without complaint, while we made our tea and missed our buses and lived our small, ordinary lives. It never announced its profundity. It just ticked. And it ticks still, even now, calm and patient as ever, while you rest, while the evening deepens, while the strangeness we have been gathering settles softly over the room. So let us pause here, just for a slow breath, and gather what we have. We have left our small blue planet, gently, and visited heavier worlds. The white dwarf, a whole sun packed into the size of a small planet, a cooling ember at the heart of an ended star. The neutron star, a whole sun and more packed into the size of a small city, dense enough that a teaspoon would weigh as much as a mountain, slowing time so much that an hour there is not an hour at all. And we have come to understand that the slowing they show us is not exotic, not rare, not a glitch, but a fundamental feature of the whole universe, present wherever there is mass, present in the earth, present in your room, present even in the small, soft difference between your head and your feet. And now, very gently, I would like to begin to prepare you for the last and strangest place we will visit together tonight. because the white dwarf slows time noticeably and the neutron star slows it dramatically. But there is a kind of object in the universe that takes this slowing all the way to its very limit. An object so dense, so heavy, with a dip in space-time so steep that it is no longer a dip at all, but something more like a cliff. A place where the slowing of time does not just become large. A place where, from the outside, time appears to slow all the way down towards stillness. A place where the seconds, watched from a safe distance, seem to stretch out longer and longer until they very nearly stop. I do not want to rush toward this place. We will approach it slowly, in our own unhurried time, the way one approaches the deepest, darkest room at the very back of the museum, the one you have been saving for last, the one you have been quietly aware of all evening. We will not arrive at it tonight in any hurry. We will simply begin to walk toward it, gently, in the next slow movement of our evening, lamp in hand, ready to look at the strangest thing the universe has made of time. For now, the table is still solid. The lamp is still warm. The kitchen clock, wherever it is still ticking its calm local tick. And somewhere far away, in the steep dips of crushed and ancient stars, time is running slow, has been running slow for ages, will go on running slow long after we have all gently drifted off to sleep. The world is stranger than it looks, and it is, in its strangeness, very quietly, very deeply, kind enough to let us rest inside it while we wonder. So here we are, at the last slow movement of our evening together. We have wandered a long way, you and I, from the kitchen clock where we began. We have visited the soft gravity of our own small planet and the high, cold orbits of the little machines that whisper time down to us. We have watched two siblings part and return across an uneven gap of years. We have stood at a respectful distance from crushed and ancient stars where the seconds crawl, and we have lowered a small lantern toward the edge of the deepest dark and watched its light redden and slow and gently freeze. We have gathered a great many strange and lovely things, and now, at the end, I would like to be very honest with you about something. Something that physicists themselves are honest about when you ask them quietly enough, in a calm enough room. Everything we have looked at tonight, all of it, the slowing of clocks near heavy things, the bending of time by mass, the soft curving of the fabric of space-time, all of this is described by a single beautiful theory, the one we have been gently leaning on all evening, the one the young Einstein at his quiet desk gradually arrived at after all his imagined rooms and falling lifts, the theory we call general relativity. And general relativity is, by any measure, one of the most magnificent things the human mind has ever produced. It is not a vague picture. It is not a loose collection of nice ideas. It is a precise and powerful and astonishingly accurate description of how gravity and time and space fit together. It has been tested, again and again, in more ways than I could list to you tonight, and it has passed every single test, every time, often to a precision that would make you blink. It told us the satellites would have to account for 38 microseconds a day, and they did, and it worked. It told us clocks at different heights would disagree, and they did, by exactly the predicted amount. It told us light would bend around heavy things, and it does. It told us that two heavy objects spiraling together would send ripples through the fabric of space-time, and many years later, we built instruments delicate enough to feel those ripples arrive, faint and faithful, exactly as predicted. General relativity has earned, many times over, our deep and quiet trust. And yet, and here is the gentle honesty I promised you, for all of its precision, for all of its beauty, for all of its astonishing accuracy, general relativity does not actually tell us why. It tells us with perfect reliability that mass curves space-time, that heavy things slow time, that the seconds run differently depending on where you stand in the dip. It gives us the shape of the thing. It gives us the rules. It lets us predict, to an extraordinary number of decimal places, exactly how much time will slow in any given place. But it does not tell us why mass should warp time at all. It does not tell us what it is, at the very deepest level, about a heavy object that makes the seconds nearby run slow. It describes the curving. It does not explain the curving. It is, in a sense, a perfect map of a country whose underlying nature we still do not understand. Sit with that for a moment, gently. It is not a small thing, and it is not a comfortable thing for everyone. But I think there is something rather beautiful in it when you approach it softly. We have a theory that works flawlessly, a theory that lets us build the satellites, that lets us predict the slowing, that lets us find our way home by the small blue dot. And underneath that flawless working theory, there remains a quiet, open question. A question that has not been answered. A question that some of the finest minds who have ever lived have looked at and not been able to close. Why does mass warp time? Why should the presence of a heavy thing slow the seconds around it? The theory tells us that it does. The theory tells us exactly how much. But the theory, for all its brilliance, falls quietly silent when we ask it why. I want to be careful here, because I do not want to frame this as a failure. It is not a failure. It is not a flaw in general relativity, and it is not a sign that we got anything wrong. It is simply the natural edge of what one theory can do. Every theory, no matter how beautiful, describes the world down to a certain depth, and then arrives at a place where it can describe no further, and hands the question gently onward to whatever deeper theory might one day come. General relativity took us further and deeper than anyone had ever gone before. It just did not take us all the way to the bottom. There is, it seems, a bottom still further down, and we have not yet reached it, and the question of why mass warps time waits for us there, patient, unhurried, in the dark. There is, as it happens, a place where physicists suspect the deeper answer might one day be found, and I would like to mention it to you softly, not because I can tell you what it says, but precisely because I cannot, because no one can, yet. You see, general relativity, our beautiful theory of gravity and time and space, is not the only great theory we have. There is another one, just as beautiful, just as well tested, that describes the world at the very smallest scales, the world of atoms and the things inside them, the world of particles and their strange, quiet dance. We call it quantum mechanics. And quantum mechanics is, in its own domain, every bit as flawless and precise as general relativity is in its. It has passed every test we have ever given it. It describes the small world with breathtaking accuracy. And here is the gentle trouble. These two great theories, general relativity and quantum mechanics, the theory of the very large and the theory of the very small, do not, at the moment, agree with each other. They do not fit together. Each one works perfectly in its own domain. But when you try to bring them into the same room, when you try to ask what happens to time and space at scales where both the very large and the very small matter at once, deep inside a black hole perhaps, or at the very first instant of the universe, the two theories begin to contradict each other and the equations stop making sense, and we find ourselves very gently lost. We have two perfect maps of the world, and they do not match where their edges meet. And in the gap between them, in the place where they fail to agree, we suspect the answer to our question may be hiding. The answer to why mass warps time, the answer to what time and space really are, at the very bottom. The search for a theory that would bring these two great descriptions together, that would let the very large and the very small finally speak the same language, has a name. It is called the search for a theory of quantum gravity. And I want to tell you, very honestly, very softly, that we do not have it. We have been looking for it for the better part of a century. Some of the most extraordinary minds of our age have devoted their whole lives to looking for it. There are ideas, beautiful ideas, partial ideas, ideas with lovely strange names, ideas that may one day turn out to be pieces of the answer, but we do not have the answer. The conversation between general relativity and quantum mechanics is, at this moment, still unfinished. It has been going on for a very long time in quiet rooms and on blackboards and in the patient minds of people staying up too late, and it has not yet reached its conclusion. We do not know how it ends. We are still, in the deepest sense, waiting to find out why mass warps time. I would like to gently refuse here to pretend otherwise. There is a temptation when telling a story like this to suggest that the answer is just off stage, just out of frame, that some clever person has very nearly worked it out, that we are on the brink of understanding. And that would be a kind of comfort, I suppose, the comfort of a tidy ending. But it would not be true, and I do not think you need that kind of comfort tonight. I think there is a deeper and gentler comfort available to us, and it is this. The universe contains a real mystery, a genuine open question, something we honestly do not yet understand, and we get to live inside that mystery and carry it with us and wonder about it in the small, quiet hours without any pressure at all to solve it. Why does time slow near heavy things? We do not know. We truly do not know. And that not knowing is not a wound. It is a kind of openness. It is a door left gently ajar, with soft light coming through, leading somewhere we have not yet been. There is something tender in sharing a mystery, I think. We have spent the whole evening together, you and I, and we have learned a great many things. And at the very end of all that learning, we arrive at a place where the learning stops and the wondering begins. And we stand at that place together. You do not have to solve it. I cannot solve it. No one watching this, no one listening, no one in any quiet room anywhere can solve it tonight. We simply get to hold it gently, the small, beautiful fact that the most familiar thing in the world, time itself, the thing that runs through every kettle and every clock and every long evening and every short morning, is, at its very deepest level, something we do not yet understand. And that is all right. That is more than all right. It is, in a way, one of the loveliest gifts the universe gives us, the gift of a question we get to keep. So let me, before we let the evening settle fully into sleep, gather everything we have touched, one last time, gently, the way you might walk slowly back through the rooms of a house at night, turning off the lamps one by one, pausing for a moment in each doorway to remember what happened there. We began with the kitchen clock, the old patient clock on the wall with its slow second hand, ticking calmly while the kettle heated and the afternoon shifted. It seemed, when we began, like the simplest thing in the world, and we ended by understanding that it was quietly reporting the local time of its particular spot in the gentle curve of the world, faithfully, all along, without ever announcing how profound it was. The kitchen clock, still ticking, somewhere, even now. We met Newton, kindly, with his lovely picture of one universal tick, the same everywhere, the same for everyone, a single calm heartbeat, shared by every clock in the cosmos, a beautiful first draft, a nearly true story. We were fond of him, and we still are. We met the young Einstein at his quiet desk, with his unread patent applications and his imagined rooms, his falling lifts, his gentle insight that gravity and acceleration feel the same from the inside, and that therefore gravity must bend time, just as motion does. We watched him arrive, slowly, patiently, at the soft, beautiful picture of space-time as a fabric, curved by the weight of heavy things. We looked up at the little machines drifting high above the roof, the satellites in their cold, patient orbits, their atomic clocks ticking faster than ours because they sit higher in the dip, by 38 microseconds a day, an amount that sounds like nothing until you realize it would unravel every map within hours. And we felt a small, quiet wonder that every time we have been guided home by a glowing blue dot, Einstein has been there, in the back of it all, quietly helping. We watched the two siblings, one staying near a heavy world, one drifting far away, parting and returning, returning and parting, meeting at last across a small, soft gap of years, having lived unequal lengths of the same life. A tenderness, not a paradox, a gentle truth about how time comes apart between those whose paths diverge. We stood at a respectful distance from the crushed and ancient stars, the white dwarf, a whole sun packed into the size of a small planet, the neutron star, a whole sun and more packed into the size of a city, dense enough that a teaspoon would weigh as much as a mountain, slowing time so much that an hour there is not an hour at all. And we understood, gently, that the slowing they show us so dramatically is not exotic, but a fundamental feature of the whole universe, present wherever there is mass, present even in the small, soft difference between your head and your feet. And we lowered a small lantern toward the edge of the deepest dark, the event horizon of a black hole, and watched its light redden and slow and gently freeze from our safe, distant view, while from the lantern's own quiet perspective, time went on ticking as steadily as ever. We stood before the strange, soft truth that the universe contains a kind of wall, not in space but in time, a place where the ordinary tick of existence slows toward a stillness no one outside can ever watch completing. All of these things, all of these strange and lovely things, each one a small room in the long, quiet museum of the evening, and at the end of all of them, the open door, the question we get to keep. Why does time slow near heavy things? We do not know. We get to wonder, and now, Very gently, I would like to bring you back to where we started, to the small, quiet room you are in right now. The lamp is still warm beside you. The blanket is still settled softly over you, or the chair is still holding you, or the bed is still beneath you. Whatever has been keeping you company through this long, slow evening, take a small, slow breath. Notice the air, moving in and out. Notice the gentle weight of your body, resting into whatever holds it, that familiar, quiet weight, which we now know is the soft pressure of a world beneath you, a world that has made a gentle dip in the fabric of everything, a world that is very softly whispering to your seconds, telling them to take their time. The strangeness we have gathered tonight does not disturb this room. It never did. The table is still solid. The lamp is still warm. The kitchen clock, wherever it is still ticking its calm local tick. Nothing in your life has changed. You still know how to make a cup of tea. You still know the way home. You still know the names of the people you love. The world is exactly as safe and as solid and as kind as it was before we began. It is only deeper now, only stranger now, only a little more full of quiet wonder than it was a few hours ago. And here, I think, is the gentlest thing of all, the small, soft thought I would like to leave with you as you drift towards sleep. Time, the most familiar thing in the world, the thing you have trusted most quietly, the thing that has run through every moment of your entire life, turns out, when you look at it closely, to be the strangest thing of all. It slows near heavy things. It bends and curves and stretches. It comes apart between siblings. It nearly stops at the edge of the dark. And at its very deepest level, no one yet knows why. The thing you trust most is the thing we understand least. And somehow, impossibly, that is all right. That is more than all right. You can rest inside that mystery. You can sleep within it. It will hold you gently, the way it has held you all your life, whether or not anyone ever understands why. So let your seconds, here at your feet, run their slow, soft pace. Let the world beneath you keep its gentle hand on your time. Let the lamp burn low. Let the room go quiet. Somewhere far above the roof, the little machines are still drifting in their patient orbits, still whispering down their signals of time. Somewhere far away, the crushed stars are still slowing the seconds, as they have for ages, as they will for ages more. And somewhere, at the edge of the deepest dark, a small light is still falling, slowly, slowly, never quite arriving, frozen in a tenderness that will outlast everything. And here in this small, warm room, you are exactly where you are, at exactly the time it is, in the gentle dip of a small blue world, held softly by the strangest and most familiar thing in the universe. Rest now. The seconds will keep you, they always have,